Hello, everyone. Uh, we are starting our today's webinar about cable fabrication equipment from TECHNO-AC. And before introducing myself and before explaining how equipment works, I would like to check the sound quality and visibility as usual. So if you can see me and hear me well, please send pluses in the chat box. And while you're doing this, I will introduce myself. My name is Dima. I'm head of technical group at TECHNO-AC Russia. I do mostly technical demonstrations, tech support, and user manual explanations and technical consulting for our clients, for our potential and existing clients. And today, we're going to talk about one of the most demanded topics in regards to our products, which is completely devoted to cable fault location. So we have a huge demand in cable fault location equipment. And TECHNO-AC as a company with almost 30 years of experience can offer the equipment, the solutions for successful high voltage, low voltage, mid voltage cable fault location. And before starting the actual demo, please let me know if you can see me and hear me well. Okay, my operator says that everything's fine. So I think we can move on to the actual explanation and demonstration. First of all, I would like to show you our test field for today's event. This is a barrel with 150 meters of cable. It's a four core cable. Each core is split here on this side. And each core represents a particular fault of this cable. We have simulated several faults on this cable. And we will be using TECHNO-AC equipment today to test if there is any fault, and we will be able to locate them. Also, we will have our AG105 transmitter, which will be creating the signal in our test cable for the test. And also a P19.1 receiver, which will be used for the cable fault location as detection instrument. And also we will have DKI A-frame sensor for electromagnetic cable fault location. Of course, each equipment has user manual in English. That's just for your information. And also we will have our time domain reflectometer TDR TA 4.7. I will explain the operation sequence for every of these devices, and we will be able to locate cable faults with all of them. So as you can see, we don't have much equipment for cable fault location on our table today, but all this equipment represents two main approaches of TECHNO-AC for cable fault location. First of all, you have to do your best in order to save the cable. You know that there are several methods of cable fault location, and one of them is high voltage surge cable burning. It means that you send a high voltage pulse inside the cable and you burn the cable till the fault is visible and detectable. In TECHNO-AC, we also have this equipment for Russian market, and in most cases for older cables and for less high quality cables, this is the only way. High voltage surge pulse is the only way. But generally for international market, we try to demonstrate the approach of saving cables. That is why we provide the solutions for pre-location of cable faults, such as um, TDR, time-domain reflectometers, and also we propose to use A-frame sensors for non-destructive, non-invasive cable fault location. Also, in order to prevent the complete damage of the cable. So let me start with electromagnetic cable fault location. Generally, this method is similar to cable tracing or cable location because you have to connect your transmitter somewhere in order to locate the cable itself and in order to locate the fault of this cable. So let us do the following. I will open one of the cores of the cable and connect our transmitter to it right away, like this. I have connected the transmitter on the other side to the grounding. Don't forget to ground your transmitter. You can see my grounding state here and the red dot that it is it's very important for any transmitter. I mean, for cable location, for pipe location, and even for cable fault location with electromagnetic equipment. And we will enable 8 kilohertz frequency signal. We will turn on our transmitter. I guess because of the sun, we will not be able to see the settings of the transmitter, but I will cover them with my hand so you can see the values on the screen. We will select 8.2 kilohertz frequency because this is the frequency supported by cable fault location equipment. While the transmitter is boosting, I will explain what kind of faults can be found with this equipment. We're going to use A-frame sensor DKI117 and receiver AP19.1. So you can find with this equipment, you can find cable insulation damage and short circuits of the cable line. Not much, but in most cases, it is what happens most. So we are going to connect the sensor to the receiver. There is an external sensor port here on the back of the receiver, but I would like you to watch the screen of the device when I'm connecting the sensor to the receiver. Just hold on a second, please. Oh, I have to. Like this. As you can see, the receiver automatically detects the sensor which is connected to it. Yeah. And automatically enables the fault detection mode, which is composed of the familiar compass and the graph, which is moving below. So, what is an A-frame sensor? The A-frame sensor is two-conductor sensor which evaluates the electric potential difference between these two legs, and it can tell where is the fault exactly. So this device is used for pinpointing the fault in the cable. This sensor has extendable legs like this. And the distance between these two legs is 1 meter. So this is 1 meter length. And also, this sensor has some controls which adjust its gain. So you can increase or decrease its gain. Now it's in a position without any gain. And what we're going to do, we're going to inspect the cable step by step till we find the fault. Let's do this on our test field and I will demonstrate it right away. So when we are going to the cable line, of course, we have to know where it's going. And in this case, on the screen, you can see the cable line in a compass mode. You can see it in the upper part of the screen. And the lowest graph indicates the signal level, which is acquired from our A-frame sensor. So you can see that our cable is here, the red one, and we're going to look the damage in this cable. And our receiver will be helping us, and the sensor also will. So how to use the A-frame sensor? First, you stick the sensor into the ground in accordance with the cable position, which is visible on the receiver screen. Make sure that the sensor legs are not touching stones, wooden objects, so they have good contact with the earth, with the ground. And then, when you have placed the sensor correctly, you can check electromagnetic signal level, which is visible on the screen. You have some signal here on the graph. This is a real-time moving graph. And it means that you have placed the sensor just above the cable, and there is no damage at all so far. And all you have to do is to follow the cable meter by meter, one by one, stick it to the ground and check the graph. You see the signal increased a little bit, but still there is no fault, there is no any signal that there may be a fault. The fault will be indicated by the significant signal drop. So we have inspected 2 points, and each point had some signal. One had less, one had more. Let's approach to the fault a little bit and see what will be the difference. I'm keeping a couple of meters just to save some time. And I'm placing the sensor again, and you can see on the graph here that the signal is still there. So this is the signal which is passing through the cable. And also you can check the orientation of the cable in accordance with the compass mode indication. And now we will meter, and we will check the area close to the fault. So now I'm 1 meter away from the fault, and actually I have my signal overloaded. You can see this icon here, and it means that signal is overloaded, and our graph is also full. And now I'm placing one leg of the sensor close to the fault and another one 1 meter away from it, and you can see that signal a little bit changed. So this is the maximum signal, and here the signal has decreased. And see what will happen when I place the sensor right above the fault. The signal almost completely disappears. It means that we have located something, the place where the electric current from the cable is leaking to the ground. If we move sensor 1 meter 1 meter forward, you can see that the signal will increase. Again, it will increase. But when we place it right above the supposed position of the fault, make sure that you have stuck, it will almost completely disappear. And that is how the location of the cable works. the cable fault location. In order to check, if you are following the fault, you can rotate your sensor vice versa, and you can check, you can confirm the actual signal here by browsing. You can do the following way. You can rotate the sensor and check if there's any signal change. And you will be able to see that you are standing right above the fault. But I recommend to do it in accordance with the cable position. So you just go meter by meter. You're checking the cable meter by meter. You go forward until you find a place where the signal is almost missing. And this is going to be the spot of your cable fault. Generally, this procedure takes a lot of time because you have to inspect every meter, literally every centimeter of the cable. And we also have an accessory for that, which is called DODK sensor. And it is used by two people, and it helps to inspect the cable the same way, but for the distance of 8 meters. It saves a lot of time. This sensor is not expensive, but it saves a lot of time, but requires more manpower. But generally, it uses the same principle as I've demonstrated to you right now. And you can use it, you can order this sensor. I'm not demonstrating it because I'm doing today's demonstration alone, but you can request it from our managers and we will provide all the information. So this is what I had to say about electromagnetic cable fault location. So we have simulated electric current leakage to the ground, and we have located it with A-frame sensor, which is called DKI 117 in our product range. Also, we used AP 19.1 receiver and HE105 transmitter. Let's get back to our table, and I will show you how to use time domain reflectometer 4.7. I will stop the operation of the generator, of the transmitter, for some time. Because we don't need it anymore. So after this demo, we will have a question and answer session. So make sure you prepared your questions for this particular method, if you have some. Let me recap a little bit the information for you about electromagnetic cable fault location. So you have to use DKI or DODK sensor in order to locate short circuits or cable faults. You can locate cable faults at the hole supported depth of the receiver. For AP 19.1, it is 10 meters. For AP 27, it is 6 meters. So you can pinpoint the location. The accuracy of this device is plus minus 10 centimeters, 10 to 15 centimeters, which means that you can pinpoint pretty accurately the fault and you can locate it pretty accurately. Also, you can use extended sensor, as I told you before, the DODK sensor, which inspects more distant area, like 8 meters or so. It operates the same way, but it requires 2 persons. And you will need that to locate the faults on a bigger area. Generally, we do the following way. We use the bigger sensor for the for fast location of bigger areas. Then we switch to DKI in order to pinpoint the fault. It works in many cases, and it works pretty fine. Okay, we will put aside our transmitter and we will take closer our time domain reflectometer. So this is the TDR TA4.7. This is the most advanced TDR we have in our range. That is why we're keeping him in stock in order to demonstrate to our clients. All our TDRs are manufactured here in Kelowna, and this is a AP54 protected with TFT color screen, USB port, multiple settings, TDR with many functions. And this particular device allows you to locate cable faults at distance up to 256 kilometers. That's a lot. That's a lot. Our TDR range starts from the locators, which help you to locate the faults in the cables with the length 5 kilometers. Sorry, and you can extend it to 256. That's a lot. That's a lot. But what's time domain reflectometry in general? You know that the market, the cable fault location market, has two kinds of devices, TDRs to offer. The first one is OTDR, the time domain reflectometer for optic fiber cables. Unfortunately, TECHNO-AC doesn't supply this equipment. That is why we're switching to the other type of TDR equipment, which is called TDR for copper cables, power cables, and network cables. And in this case, our equipment suits the best application for the location of twisted pairs, coax cables, and power cables. This particular device is the most powerful, but the principle behind this device works for every model of TECHNO-AC TDR. Let me turn on this device. I'm not sure that you can see the screen, but I will close the lid a little bit so you could see what's happening on the device screen. It is boosting, it's booting, it's software, and this particular device is mostly used for the location of the most complicated low and high resistance faults. So as this device is mostly used for power cables, you have to observe safety precautions before using this device. First of all, you have to discharge your cable, and then you have to use megometer to test the resistance of the fault which are happening to this cable in the current moment. So when you have done all the precautions, you have to connect the crocodile clamps of the cable to the leads, to the rods or conductors of your cable. Usually you do this on your substation or in a junction box, but today we're going to locate the faults in our test cable. So I'm removing the safety cap here. Of course, this cable is completely discharged and it doesn't carry any current or any voltage, as far as I know. We're connecting the crocodile clamp to our cable, and we also have connected the wire, the other end of the wire here, to a TDR connection port. So how TDR works? TDR sends low voltage pulse inside the cable, and if there is a damage in the cable, this pulse is reflected and sent back to the TDR. Then this device evaluates the time and distance and speed of the return pulse, and that is how you can calculate on which distance you have your fault, and what kind of fault is that, and what is the overall length of the cable. So let us start the measurement and we will see together what does this device indicate. You can see that device is showing some graphs which may be hard to interpret in the first place, but if you read the user manual, you can try, uh, you can find out how to interpret the meaning of this graph. But I will give you a small advice. When you're placing the cursor of the device on some major change on the graph, like we have here, this one, this square indication, most likely that we're having a damage of the cable here. So you can see that when the graph goes up, this is a complete damage of the cable. I will close a little bit so you can see. And TDR inspects two cores, two conductors of cable simultaneously. And when we are inspecting the cable, we may tell, and when we see the graph like this, we can tell this one, yeah, this one. We can tell that there is a complete damage of the cable, so the cable is broken. And let us go and check for 20 meters or so. Don't forget that we have approximately 10 meters here of the cable, and we can go all the way. Of course, in a normal situation, we will have to dig the cable out, but this is our demo cable, and that's not a surprise that the cable damage will be here because our current is leaking from the cable to the ground. That is why we can detect this. So yes, it's approximately 20 meters of our connection point, the cable which is on the barrel. But let us switch the conductors of the cable. I will switch the connection of the TDR to other conductors of the cable, and we will see what the device will tell us, like a fortune teller. Let's do it like this. And now we have switched the conductors of the cable, and you can see at the same distance, the graph is going down like this. It means that these two conductors, the gray one and the brown one, are having a short circuit. One of them is connected with each other. And it means that anyway, you have to dig them out and you have to test and you have to see for your own if there is a damage. But you know the distance. You can use your cable locator to trace this cable for this distance. You can dig out your cable and repair it in no time without damaging it with high voltage transmitter. But if you like using high voltage transmitters, there is an option for you. As you can see, there are two BNC connectors here. One is called trig and the other one is called wave. The trig is used with high voltage surge wave transmitters. So if you connect this TDR to a high voltage surge transmitter, you can amplify the pulse which is sent to the cable. And if you have a high resistant damage, you will be able to reflect it from the fault and send it back to the device. And that is how you will be able to locate high resistance cable fault. Also, this device can locate as we could see right now, the following cable damages. Now, the open cut of the cable, the short circuit between two conductors of the cable. Also, this device can detect joints, cable joints. Also, it can detect the watering of the cable, and it can detect some other minor faults or minor repairs of the cable, which are not visible by any other device except for your own eyes. Okay. Also, this device has a built-in 12-volt accumulator. It has color TFT screen, as you can see, and also it has a memory inside it, and you can upload the data to your USB flash drive and later upload it to your personal computer. And this device is available in multiple languages: in English, Russian, Spanish. It is available in Spanish. And also, it is IP54 protected, so you can close the lid and you may be sure that rain will not damage this device while you're connecting it to the cable. Yeah, so this is your TDR. This is TDR 4.7. This is the most advanced. We also have smaller models, portable models. We have a model which works only with a laptop, which you can use for your building network, for your coax cables, twisted pair cables, and so on and so forth. So this is pretty much it. Almost pretty much it I had to say for today for cable fault location. But I have another small addition to to make, another small announcement to make. You may know that on our website you can see acoustic fault locators, which generally work with high voltage surge wave transmitters. And you also may know that we didn't have the transmitter itself in our range because of our approach, but we feel that there is a huge demand in the worldwide market for this kind of transmitters. That is why I have a small announcement to make. We have such transmitter in development right now. So we're going to design our own high voltage transmitter, which will be working with this TDR, with our acoustic fault locators. And hopefully next year we will have something to introduce. I think that this is going to be MVP one for this product. But anyway, it will be fully functional demonstration unit. I really hope so. And hopefully next year we will launch a complete set for cable fault location, which will be composed of electromagnetic, TDR, and acoustic. So it's going to be electric test van without a van. So all you have to do is to put this equipment in your personal van or in your business van, and you will be able to check for cable faults on your own with observation of all safety measurements. Of course, nothing happens without safety. Okay, I think I gave you pretty much all the information, but traditionally we have small question and answer session in the end of our event. That is why I'm taking my phone, and I will see if you have any questions for me. Just hold on a second. I will open my app for this event, and I will open the chat box. Yeah. Okay. Can I use the DTI on the paved road? Yes, you can use the DTI on the paved road, but make sure that you are not pushing the legs too hard because it will damage them. Yeah, you don't have to hard, but you can use DTI on the paved road. Yes. Is there an impact of other electrical signals in industrial environments of electromagnetic device? Is there any limit or does it not matter? Uh, you see, for electromagnetic location, you are using a particular frequency, 8 kilohertz. And this frequency should provide the safety from other industrial frequency sources. It means that if you're working on a particular frequency, no other device will support this frequency. That is why we're using 8.2 kilohertz, just to be sure that there will be no industrial interference. What happens if the failed cable is shielded? Does TDR have a different result? The TDR will not have different result because generally you connect the cable to the conductor. You connect the TDR to the conductor or to the shield. If you're testing the shield, you will get the fault of the shield. If you're testing the conductor, you will see the fault of the conductor. How to connect surge generator? I wish I could tell about it more to you, but we don't have surge generator now. But if you are talking about the TDR, you can connect it here to the trig port. And this is a normal BNC port, which is supported by most uh, high voltage surge transmitter. That is why all you have to do is connect your transmitter here. Matter is only price. Up to what kV will that surge generator will be? I really hope that it's going to be up to 35 kilovolts. We are testing several models now, only electronic units, but hopefully this is going to be 35 kilovolts and something about 3,500 joules of power, which should be enough for most cases. Yeah, hopefully next year we will be able to test it. I don't know how it's going to look in online demo because there are a lot of safety precautions to be observed. We will see. We will see. Maybe we will make a video. I don't know. Because it's too dangerous to demonstrate it online. Okay. Any other questions? Any other questions? I will be. I'm happy to reply. I guess no. I guess there are no questions. Okay. What is the IP protection of TDR? Yes, IP protection of TDR is IP54. It's not completely sealed from water because you can see that face panel is not completely sealed. But generally, the humidity and the small rain is not affecting this device. And the overall case is protected from water. Okay, if you have any other questions, I propose you to send me an email on my address. I will post it in the chat box right now. It is consult@technoac.com. Here, I have posted it to the chat box. You can find it here. Also, I have a WhatsApp number, which you can find in my email box, in your inbox. And also, Skype, email, WhatsApp, any other way. Also, let me remind you that you may have a private demonstration or private training for any part of our equipment in Zoom, WhatsApp, Skype, wherever it is. We can do it for you, for your client, for you in particular, for your team. It doesn't matter. We do this completely free, and we provide full 24 by 7 support for all our products which we supply from our factory. So thank you very much for your attention, for your time. This was not the longest demonstration that we had so far, but I think it was pretty useful because we have covered some new equipment which we didn't cover this this in the last month, I guess. Okay, Thank you very much. Thank you for your attention. Take care. Stay healthy. And hopefully in 2 weeks, I will find something interesting to you to show, to demonstrate, and to give some training. Thank you very much. Have a nice day. Bye bye.